It's a real pleasure to have with me here Andy Sadhwani, who is an aerospace engineer at SpaceX and who uses simulation in his work. And he will give us the industry perspective. And in fact, the module that we're going to go through, the bolted nozzle flange, has been developed with help from Andy, and it's based on a model that Andy developed. So I want to ask Andy some questions about how simulation gets used in industry, and then we'll have, we'll talk to him about specific things regarding his model in ANSYS. Good morning, Andy.
Good morning.
Thank you very much for joining us in this call.
My pleasure.
And I've been having, I've learned a lot from your model, and I'm really excited to give students an opportunity to go through it and learn about how to take, fundamental knowledge of finite element analysis and apply it to something that's very real and very practical and very exciting. So thank you for that.
Got it.
I want to start off by asking you, how do you use simulation in your work in the aerospace industry?
Okay, so simulation is used here in aerospace when hand calculations are not sufficient. So many things can be sized by hand calculations. That could be bolted flanges or the sizes of tubing or how much pressure drop you get across a series of elbows and 90-degree bends. However, when it comes to what happens to the combustion products of, say, two liquids that are impinging in a combustion chamber, or what kind of flange gapping do we get when we have a nozzle connected to a thrust chamber under a very high heat environment, under a lot of vibration? Those are second and third order. Those carry second and third order effects that are hard to capture by hand calculations. So that's when we use simulation to answer the questions that we cannot.
Okay, so you still need the hand calculations, right? That's what you start off with.
Yeah, definitely.
Yeah, and that's something we show through your
Well, yeah,
model
I'll bring
too.
it up.
And we'll lead students to the hand calculations that you have
Right.
indicated, for that the bolted nozzle flange.
Yes.
And so you've indicated some of the benefits of using simulation, and they need to be coupled with the hand calcs. What are some of the challenges of using simulation?
Exactly. So many benefits of simulation are, of course, doing increased complexity in physics, and which gives us the ability to decrease the amount of time it takes to go from product, like idealization, to creation, where you can start developing the product and making revenue off of it, so you can build the company and keep going forward. It definitely drops the amount of time take to do prototyping and the analysis design cycle. Now, the complications are it can be very easy to use the simulation products, especially some of the easy to do steps. However, it definitely becomes more complicated in interpreting results. So, for example, in this nozzle example, we load it up with pressure, and it's got a temperature condition, and then we get deflection. Okay, is that correct? Are the stresses that we see correct? So we'll get von Mises stress. How about the principal stress? Does the principal stress match with the hoop stress that we would calculate? Is the nozzle in compression or is it in tension? So when we do a free body diagram, we would see that it would be in compression. However, is that what the model sees? And another one would be, is everything modeled correctly? Does it pass the looks right test?
Mm-hmm. Okay, and we will be doing some of that, as we go through the model and ANSYS, and students will be able to follow through using the videos.